Hey folks, welcome back again to Advent of Code in F#. We are day 2 already and the puzzle will be unlocking really soon, so I suggest we just dive right into it. Yesterday was a bit of a warm-up, I was a bit rusty, so I hope today will go a bit smoother. Seems to be popular this year, or my internet is very slow. Both could be the case. Oh no. I have internet, sadly. It's the website today. Hug ups, Eric and team. Hug ups. That's the first time in years that this happens. And there we go. Good job. Day 2, red-nosed reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion fission plant, that's a callback to 2015 even, if I look at the hyperlink. Insane. But it appears to contain no sign of the chief historian. The engineers... Oh, will this be a best of? Will this year be like a walkthrough through all the previous years? That would be cool. But anyway, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They are quick to add that since you're already here, they'd all really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. So we decide to program a little. That's a typical IT-er. The unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. Okay, makes sense. Numbers, reports, levels. This example data contains 6 reports, each containing 5 levels. Engineers are trying to figure out which reports are safe. Red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So a report only counts as safe if both the following are true. It's always going up or down, and there is a difference by at least 1, so it has to change, and it cannot change too much. Okay. Reports can be found safe or unsafe by checking rules. So we have to iterate over every report, check the levels. They have to be strictly monotonically increasing or decreasing, and there's a lower bound and an upper bound. That sounds doable. And we count the number of safe reports. Cool. Let's grab the example. There we go. And let's grab our actual input. That's too bad. Okay. Our input is crashing, but we can work with the example for now. So let's parse our data first. Lines is a string list. And let's map over our lines. And do a line dot split on space, so we have every number individually. And let's map on every number so we can parse it. This is exactly what we've seen yesterday. So it returns a list of an array of ints. Let's also make everything a list, make it consistent. There we go. So let's parse the example, see that we get everything right. We did not. Okay, that's better. 7642 13679. Yeah. Okay, so now we have to iterate over every report and determine whether it is safe. So it's filter, for example. So these are all the reports, and for every report, we're only gonna take the safe ones. And that's a new function. And we just need true, false, yeah? Yeah, we just need to filter out the list. Reports is not defined. Oh, that's my bad. Okay. How does a save look like for a single report? What does that look like? We iterate over the report from left to right, and we check these two rules. We have to compare against the previous one. And the levels are either all increasing or all decreasing. What does that mean? How do we do that efficiently? We have to detect like whether we're going up or we're going down. Sorry, I have a bit of a dog hair in my morning coffee. That's not great. So how do you do this? You can take a look at the list, see if it's sorted. That might be the easiest one. Maybe if I know how big our data set is. There we go. Oh, it's actually not that bad. Yeah, maybe it's easiest to check whether the lists are sorted. And then we just have to check for the difference between 1 and 3 part. Otherwise, we have to do a bit more of shenanigans. Yeah, let's do it like that. So a list is safe, or a report is safe, whether it's monotonic. So it's strictly increasing or decreasing, and within bounds. Can my writer help me out here? Introduce variable. That's not very. Is it? Let's see. Let's see how far it gets us. Nah, it does not get us very far. Okay, so let's just write these two little helper functions. And the second one. Don't like my naming consistency. There's no is, so there we go. Is monotonic, that's just either the list is sorted or the report is sorted in descending order. So I'm just gonna calculate the two and compare it with the original report. It has to be one of these two to be a monotonic, increasing or decreasing report. It's not the most optimal way of doing it, and we'll be looping a lot over the lists, but I don't think our data set is big enough to worry about that. So that's the monotonic part down, and then within bounds, we need to take a look at a number and the previous number and check whether it grows between the bounds. Whenever I have to check a number and a previous number, you can use several functions, but there's one that's great for this, and it's called pairwise. Let's take this. Pairwise returns a list of each element in the input list and its predecessor, with the exception of the first element, which is only returned as the predecessor of the second element. So here we let's make it concrete with an example. We take pairwise of this list. You see it's like 1, 2, 2, 3, 3, 4. So it's all the elements pairwise, and then we can take a look at a number, its predecessor, and determine whether it's growing within the bounds. So we can use it here. Report pairwise. So now we have all pairs, and for every pair, the bounds check must hold. So that's something we can do with a for all. It takes a predicate, and the predicate has to be true for every tuple in this pairwise list. So that's great. X and Y, and then the difference between X and Y. We've seen that yesterday. I'm just gonna write a little helper function to make this to extract the logic a bit. So within bounds X and Y, and that should all work. That should all work. Cool. So X, the difference is absolute value of X and Y compared to each other, and then the difference has to be smaller than or equal. Let's see what they're asking. At most 3. So 1 is okay, 2 is okay, and 3 is okay. At least 1, at most 3. There we go. I think actually this might be part 1 done. Let's see whether we get something out of there, and if we don't, we can write some tests for the things we did. So I have 2 lists, 7, 6, 4, 2, 1. And 1, 3, 6, 7, 9, that looks correct. And then we just count the number of lists. And that should be good. Let's see if this works for our actual input. I'm gonna grab the parsing, so everything above is just function definitions, and this is the actual thing. And let's use our input instead. Interesting. Oh, my input file was empty when I ran that line of code. So let's rerun this line of code. So it grabs my actual input way better. Yeah, and let's see if this is performant enough. Oh, it flew by. Great. It's day 2. Not too hard just yet. That's great. Good job, us. Ready for part 2. There we go. Let's clear the terminal. And let's take a read. The engineers are surprised by the low number of save reports until they realize they forgot to tell you about the problem dampener. Ominous sound. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a save report. Ooh, interesting. It's like the bad level never happened. Okay, this is where performance might come into play. So we can ignore one single number in a report, one single level. Maybe our sort approach will bite us in part 2. What's the easiest way I can think of? Just nibble out every number and check the report for all the possible subsets. Yeah, I think that's the most straightforward way. So let's start by doing that to get a feel and maybe potentially solve it using a naive approach. So it's actually exactly the same, except where we do our isSave. We have to not look at the report as such, but we can introduce all the different possibilities. And if at least one is safe, the report is safe. So isSave here can grow. We just loop over all the different corrected reports, or where we use the problem dampener module, and then if we hit a single one that's safe, it's okay. So let's generate some cases. So what would we call these reports where we delete a single level? let's just call them whatever. So I'm gonna call this shorten, for lack of a inspiration, and that generates like a sequence of all the different shrunk reports. It's called shrink. How do we do this? There's a remove at, and it takes an index. Oh, this will work. Now I'm going to drop from list to sequence to keep things lazy. What I'm doing here is called a computation expression, but it's whenever you see me do this, this is generating a list with elements from 1 to 10. And the thing I'm doing above is the same, but now I'm returning a sequence instead of a list. And that's a bit like the C# IEnumerable. It's lazily evaluated. And then we can loop over all the shrunk reports, and we don't have to generate them all, and we can stop at the first save report. That's a bit of my thinking. That's what's going on here. So we generate. I think I can just do list remove add. Yeah, we'll get there. So for report list length -1, remove at I. So we loop over all the indices. What's going on? A lot is going wrong. Okay, compiler, you can help me now. Why am I not seeing what the squigglies mean? Okay, the type integer does not match the type of the function type. Okay, let's extract some variables here. I'm not seeing what the problem is. Oh, list length is a function. I have to apply that to something. I had my parentheses wrong, of course. So I'm guessing that this shrinks a report. Let's try that. Shrink 1 to 3. 2, 3, 1, 3, 1, 2. That appears to be correct. Yeah, that appears to be correct. So we have now shrunken report generator, and we can use that in our original isSave, or we can just wrap a new isSave around it. When I'm doing functional programming, or no, when I'm programming, I like to build up on building blocks, and this original isSave looks like a building block, so I'm just gonna bolt something on top of that. I'm thinking maybe this is not correct yet, as in the shrunken report, all good and well, so that'll work, but we have to take a look at the original list as well, yeah? So I'm gonna also have the shrunken sequence generator return the original report. So that's also in there as well. And you can do that with a yield instead in the sequence generator. So now let's verify whether or not that works. And I'm gonna put it in a test actually. So let's shrink this list again. Yeah, that looks correct. And let's grab this. I'm gonna encode this for posterity in a unit test. Let's see if I can just compare against the sequence statement like this. Not sure. Oh dear Lord, stop removing. Okay, let's see if this works. No. I think it's because I'm using the sequence generator here. I'm gonna do it differently. I'm gonna cast the result to a list, and I can compare two lists. Of that I'm pretty sure. No? Oh yeah, it is, sorry. I was confused. My own hand-rolled test framework output code was confusing me, but yeah, that works. If I see testing done on a single line without like an error in between, that means the bar is running green and the test is succeeding. Maybe a quick zoom in, what is this? This tests and then the weird symbols. It's a library called unquote, and it uses quoted expressions. You can think of quoted expressions like meta-programming things you can do in C# as well. And in these quotes, that's why it's called unquote, or that's why it's called quoted unquote, because we're using quoted expressions and they're like evaluating them step by step. But the real neat feature of this library is that whatever you type in here can like return a true or false. And if it's true, the test is succeeding, otherwise it's failing. But the interesting part happens when the test is running red when it fails. Let me introduce a bug here. And let's rerun this test. Let's take a look at the output. So it's saying test failed, great. That's what every unit test framework in the world does, but it's doing more, as you can see. It's like taking steps. It's step by step, it's evaluating the expression. So this is my original line, and then it says, okay, let's run this range here to generate a list, and it's really expanding it so you can see what's going on. And that enables me to write my tests a bit higher level than I would in a language like C# or using other frameworks, because the test is giving me the level of detail I need, but I still don't have to write the level of detail I need, because it's automatically evaluating the steps in between, which is a nice trade-off. Anyway, I digress. We were working on part 2, we were shrinking reports, we were using sequence generators. So yeah, let's finish up on that part. So let's shrink the report. Those are all the cases. And then we just need to find one safe report in there. So if any, what's the any exists? Yeah, we had a for all. We used for all. Now we can use exists. It's the same thing as a for all. But if there's one case where the predicate returns true, then it stops. So that's exactly what we need. So for all the shrunk reports, let's see that we do it correctly here. What even is a report? Oh yeah, that's all correct. There we go. So for every report in the shrunken set, we check whether one of them is safe, and that's good enough. So instead of using our bare bones is safe, we can use our is safe shrunk alternative, and we can run this on the example to make sure it works. I'm gonna reload all our code to make sure our tests are running. No, still have my bug in there. That's the problem with defect injection. You have to make sure you remove the defect. There we go. So for the example, we're getting 4. That's actually correct. Now I hope our CPU will not explode if I run this on the actual input. And otherwise we have some optimization to do. Actually, we have no optimization to do. That went way faster than I was expecting. And that's even correct. Good job, us. This was a fun one. Yeah, so let's do a quick recap of today and talk a bit about the things we used. We don't have to look at part 1 because part 2 was just a more complicated version. So we had reports containing levels, and we had to do a check to determine which reports were safe. Safety was monotonically increasing or decreasing, and they have to decrease within certain bounds. We did the monotonic part by just comparing the original report with the sorted reports. That's not the optimal way to do it, but it was good enough, so it was an easy one-liner. And then the bounds check, same thing. We already did a distance calculation for day 1, and here it is again. The new things we did today was working with some new list module functions, the pairwise thing to look at an element and its predecessor, which was very helpful for today, and for all and exists, two functions that have a predicate and it returns whether or not the predicate holds for every element in a list or for a single, of whether or not there exists a single element. Last funky thing we did, new thing we did, was this sequence computation expression, and that's an alternative to that list generation thing you saw me do a couple of times. But the benefit from using sequence instead of lists is that sequences are the enumerables of F#. They are lazily evaluated, so we did not have to generate all the shrunken report cases just to check whether or not a single one existed that was safe. This logic will stop generating shrunken reports if the first one, on the first successful is safe evaluation. And that's why we went through the lengths of this somewhat arcane syntax or unfamiliar syntax, especially with this yield and then this for. But if you know Haskell or Python, I guess it's not that bad. That exists as well in those languages. Yeah, and we took a look at our unit test framework, unquote, and a hand-rolled run method. And that's how I do my Advent of Code stuff. For production work, I use more familiar tools like XUnit, but for scripts like this is just fine for my tastes. Yeah, this was a fun puzzle. I had a lot of fun. I hope you did too. And in that case, I would love to see you again tomorrow for day 3 of Advent of Code in F#. Bye bye.